Well, hi and welcome to my shop, and thank you so much for joining me here. A whole year has gone by since the last video. It's now 2021. Holy smokes. I remember, when I was a younger guy, say in high school or college, I just couldn't imagine being alive in this year, but here I am. And guess what? That radio is also alive there. And I've been trying to think about what am I going to do now. I had huge success yesterday with it. I plan to continue the success. Clearly the radio was in a state where it could have operated right from the start here. I've simply restored it back for the most part. So what to do? I think what I like to do is operate the radio and then test it, and measure it, test it, do all kinds of stuff like that to get before I start altering it in some way. I don't want to alter it. In order to get a real good grip on just how it's working. It's a simple radio. I think I have a grip on it already. I think that's why I made it work yesterday. But without really looking at, frequencies that are in it, signals that are in it, and stuff like that, really don't know. So I guess that's the name of the game. Get to know what's going on here for sure. So I'm going to stop the video, turn everything on, get everything operating, and then we'll carry on. Okay, I think I'm ready to start applying some voltages here. So I have an antenna hooked up to these terminals. I put some new wires in here. So they're going to the steinite coil to start off with. And I brought a new meter into the picture. This is an audio meter. It's connected to the output, same place the signal tracer is. And you can hear the hum from the tracer waiting. Used a capacitor to try to block the DC from getting onto my meter here, so we should just see audio on here on this meter. I have my SDR antenna ready to do this kind of thing, just all over the radio, see what's happening, what we can see on the SDR. And but the main thing, first thing, is get a station received, and then from there we start playing around. So next step is to apply the filament power. Okay. There we go. There we are. Tubes are lit. Now I still have the B+ meter sitting. I put it up here. Let me just change the lights here a little bit. Ooh, that's really dark for me, but that's okay. So this is the B+ meter now. Now we're going to raise the B+ on the radio. Must be some kind of discharge in the capacitors that causes that. So it's a 50 volt scale, and we're going to work our way up to around 40. And you can hear the radio. Let's put it right around 45. 45 is what is written on the radio itself. Okay, so, well, we got sound coming out. This meter is indicating something, but we can't be sure what it's indicating just yet. So, let me change the volume setting on the radio itself. We'll see what this meter does. I can't turn it. There we go. So it's not doing anything. So it's it's doing a little bit there, but I don't think we can trust this right now. But we'll leave it there as it is. How about a radio signal? We'll just wing it here and see if we can find something. Uh-oh, that's not good. Hey, how about some? I have B+. Yes, B+ is going. We're out of business already. I think I know what the problem is. I think there's a problem right here on this connection. Okay, need a little more light, please. Yeah, I don't think I resolved this connection here. I did not. Bring a little piece of wire around here. I kind of forgot about that. Okay, let me hook that back up, and we'll be in business then. Okay, got that connection done. Let me just turn off the soldering iron because it causes interference. Up with the volume. Well, that sounds a little better. Now I'm going to try to tune something in here. Okay, where do we start? Well, we've looked at the local oscillator a number of times and seen that it produces a number of multiples of the local oscillator and probably even goes lower. It's maybe starting way low. And we're just using one of the oscillations that happens to be in the right spot for this radio. So some curiosity about the IF here. Now, let me turn it down. My signal tracer is designed to tune IF frequencies so you can follow them through a radio, but it doesn't go as low as this. It only goes down to 170. This I think is at 80, 85, somewhere like that. And that's kind of odd. Maybe we could start there, in fact. Why don't I just move my sniffer coil around the radio and we'll watch the SDR and we'll see what happens on it. Okay, there's the SDR. I'm going to wiggle the oscillator so you can spot it on there. It's right around 600. Just fine tune it. That's really pretty good tuning. Okay, that's dead on, wherever it is. And where is it exactly? So offhand, we don't know what station we're listening to right now. If you subtract 85, you go below the band. So you add 85, and this is 7. That doesn't make any sense. Okay, didn't make any sense. Now I'm going to start. The pickup coil is actually quite a distance from the radio, so I'm going to start moving it around. So first I'm going to pass over top of the radio, starting at the antenna end and just going across, just to watch what happens. I'm about 4 inches above the radio. So you see something very strong show up around 1200 here. Now I'm going to put this right over the oscillator coil. How do you like that? So you see very strong at 1200 and very strong at 600. And again, there's another one up, another probably at 1800. Now there's other signals showing up too. I'm just moving it in and out. If you look 500 to 600 in that range, I just move this away. A lot of strange things going on. I'm moving it back up. I'm going to put this on each tube, the top of each tube, one at a time. We're going to accept one tube, next tube, next tube. I'm getting close to the oscillator when I'm doing this. Not the oscillator tube, but so that didn't really, nothing too revealing there. Now I'm going to do each of the transformers, and we're hoping to see something around 800. You know, that's way on the left of the screen, just below the 100K mark there. Okay, I'll try the last one. It should be the strongest one. So there are definitely signals in it, or signals being picked up. Now, I'm going to have to change the camera so you can see exactly what I'm doing in it. Interesting enough, it seemed to shift the frequency of the 1200, but not the 600. It's probably shifting them both, it's just I can't see it at the 600. Brings in a signal we can see now at, I guess that would be about 540. I'm going to change this so you can see what I'm doing with this coil. Okay, let's try that. Now you can see what I'm doing, you can see the result. Bearing in mind there's a 1-second delay. So oscillator coil is here, so if I come over to the oscillator coil, I get a whopper of a signal on there. Strongest one definitely is the one at 600. Now if I try the coils here, so this is the weak end. If I go down to the strong end, something shows up at about 5, right at the bottom of the band. We can listen to these things. So what I can do is I can shut the sound down from the radio. We can turn the sound on the SDR. And then I can tune the SDR. I'll tune it right on top of this. And that's the sound. So there's no signal there. There's no modulated signal there. Okay, so moving the coil. Okay, another very odd thing is happening. If you look right at 500 with the coil here, you see nothing. But if I take it away, these signals show up. Now this could be AVC thing happening inside the SDR. Doesn't seem to be. I get a kick when things are happening. I have no idea why this is happening. So is there a now I really want to pay attention to the 80 kilohertz area. There's nothing happening there. Okay, I'm going to put this on the last transformer. And we're going to tune the radio a little bit and look right around the 80 area. 80 is down here. And watch for some kind of indication of an IF kind of thing. We don't have to listen to this side. We don't have to listen to this. So I'm going to turn up the radio a little bit, just so we're aware. Okay, tune a little bit and watching for IF activity somewhere up there. I know what it looks like because I've seen it in other radios. I don't see anything happening at all here. I'm looking all over the place now for anything that looks like an IF activity. I know what I'm looking for, and I do not see it anywhere at all. Oh. Huh. The mystery continues. How can this be so mysterious? How can this be? Why am I not able to see it with my coil here? No wonder people never know what frequency this thing's running at. You know, I could do a more direct, I think I'll have to do a more direct connection of the SDR. Or is there a better place to pick it up? Being right there? I don't think so. Well, it's also possible right on the capacitor here. Whew. definitely getting a lot stronger signals in here. The jumping around is the shorting out of the capacitor. I think I see it. I gotta tune up and see, just keep watching what I'm watching. I don't know. So I'm looking right in the 80 kilohertz area, and so what it looks like when you look at signals passing through an IF is a small, on an SDR, it'd be a small area on the SDR, where as you tune up, you see things popping up and rolling, popping up and rolling back, popping up and rolling back as you tune up, 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 up. Just this one area, you see things. And those are the 455, or in this case, 80 kilohertz signals, manufactured signals, products of the mixing process coming through. And they roll off quickly. So they're contained in a small area, like in the case of a regular radio with a 455, they'd be contained in like 445 to 460, somewhere right in that area. And you just see them grow and then disappear. They just march through as you tune the radio. Don't see any of that here at all. Don't see any of it. My only assumption is it's just not enough juice for the SDR to show it. The problem is the local oscillator is very powerful, and if I continue to allow more and more signal to go into the SDR, I'll blow the SDR front end up at some point, I would think. Is there some way to get up? You know what? You know what I could try? Why don't I try yeah, that's a good idea. I'm going to try the sweep generator on this and see what we get out of it. Okay, I think I'm ready for this. So I have the sweep generator sweeping from 550, it's the lowest I can get it to go right in this particular setting, up to 1615. Let's go just a touch higher. Around 17. Okay, 1650 is as high as I'm going to go. And we'll start sweeping. Now it's sweeping at a high rate. We can't hear it. Why are we not hearing it? Because there's no signal strength coming from it. So that's the sound of the radio there. There we go. So I'm going to turn down the speaker here so we're not listening to it. I don't see it on the scope because I don't think I have the scope set right here. Okay. Scope is now tracing based on the sweep. We're still not seeing anything because I don't think I actually connected up the scope lead yet. Okay, so I have the ground, scope ground connected. First place to go looking now, bearing in mind the scope itself. I've got this on the times 10. The scope itself can throw these circuits right off while we're trying to, so we can undo what we're trying to do here. There be the sound. Let's just start right here. Output of this tube. Change the output at all. Try to get it to trigger. Oh, there's no triggering. What am I saying? This isn't triggering. This is a sweep. 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 So it's just showing me a steady. What is it actually showing me here? Once again, unexpected results. So what I'm hoping to see is the converted signal. But what I should see actually is everything. I should see the incoming signal. That's probably what's there. You know, I'm going to go on the output of this transformer on the counter. Now that's going to go on the grid of the next one, so that might really affect the radio a little bit. So hopefully what I'm getting is less of the original signal and more of the 180. And I can see that there's really nothing showing up here now. Let's turn down the volume a bit. Turn up the signal strength. See a little tiny thing showing up way down here. So this cannot show a frequency that is not in the sweep range. So if I want to sweep, up here in the radio, and then radio range, and then look down here, trying to see what's going on in the IF, not happening. Not happening. Unless I sweep the whole thing right down to IF frequency. So I saw a little thing down here. Maybe. I don't know what that was. Let me just turn it down again. Is there a more sensitive place? So I'm still right at the front of the radio. Let's move downwards here. I'm going to reconnect. Say on the third transformer. This is the. Okay, so we got a little blip there. Let me go a little further down. I don't know what the blip is. So this is the real output now. This is kind of what we're listening to. Okay. Now tuning the radio should not have much effect on this. Well, there you go. So there should be a signal all across the band here. Only if I put on, turn on the, the sweep is running. Why am I not? So as I tune, there should be, that stuff should move. Oh my gosh, look at that. What's this telling me? That the radio is only working at this end? Oh, you know what it is? It's the other tuner. Maybe the other tuning knob. Let me try that. Look at that. Oh, you can see it select those two signals as I'm tuning through it. Left one, and then it picks the right one. Very cool. So that is actually an interesting thing what I was doing there. That's the front end resonance. Again, that should be traveling along as I tune this. It shouldn't just be getting louder and louder. There's the travel part. Yeah, I'm not saying much because I don't know really what to do next on this. So that's the oscillator changing. The oscillator's coming into the range of the front end tuning. You can hear the background noise coming up. So I'm tuning through the front end tuning here. I'm passing the local oscillator through the front end tuning. And so if I move the tuning and pass it through now, it'll be a different spot that gets boosted. Very good. If we want to boost way up here, turn the tuning knob back there. But it's not delivering a peak as such. But it's working up in that range. So fairly sharp tuning here. We still don't know what the IF frequency is though. What a stupid situation. So we're scoping. So that signal way at the left there. Could that be little tidbits of the IF? What you need to do is, hey, what's going on the SDR? Let me just take a peek at it. And we would want the coil. Just bear with me here a second. business end. And you know, signal has shown up in the IF range. Let me tune something here. And turn this knob too. Yeah, I think it's a nonsense signal. It's just no. It's just no. Oh, I kind of lost track of what I'm trying to prove out here. Trying to find the IF frequency. Trying to understand the range and limits of the radio. Why am I not able to determine the IF frequency of this radio with certainty? Let me change the sweep so it actually starts below 70. Let's try that. We think the IF is 80 or something like that. I'll put the start frequency way down to 45 kilohertz, 34 kilohertz. Start it there. So on the screen, what it's done is it's basically got more here now. So in effect, this stuff gets moved over. So down in here now is the IF. And what do we see down there? Tune the local oscillator. There's an interesting question. That's the end of the run there. It's an interesting pattern there, right? The four things do appear to have a pattern to them. Why is the hiss going up and down like that? What's happening at this point? The radio is not connected to an antenna, but it is connected to wires. So it's some kind of a... I don't know. Just put it on the list. An effect I don't understand exactly. Seems, though there's no AVC in this radio. No AVC, as far as I know, there's no AVC. And so a noise signal should come through at the same level whether there's a sweep on top of it or not. Is that true? Stop the sweep. So that's the noise there. I can make my scope sweep more normally here. Tuning the local oscillator. Ultradyne sound. So I'm up now. I have to turn the other tuning knob to. Was it two peaks as I turned it there? 1, 2. Number 2 seems a little bigger. Now what are those things traveling along there? I think I'm just basically tuning in noisy spots here. Like this is a noisy spot. You know what? Let's go back to the antenna. I like hearing the radio operate like a radio. Okay, we'll fool around with... Whoa! Ooh, what's that stuff? strange things. So we're going to tune the radio to around where we were getting stations before. Quieting. Flexing the capacitor under here. Nothing dramatic there. Let's put the loop antenna on here. I still have it here. Let's see what we can get out of that. Because the wire antenna comes with all that noise, and it gives you a false impression of how good or bad this radio is operating. The radio should get quiet when I do this. Good. You can still hear the static, it's just much lower. But in place of it, I should be able to generate strong signals from the loop antenna. This is tuned into something. My antenna apparently isn't. Let's see if we can make this work now. Now we have a good signal coming in here, no doubt about it. A little action on the meter over here too, but not sure what this is telling me. This may be telling me that there's an audio oscillation here that's beyond our hearing. We can't hear it. It could be that 80 kilohertz signal could be sitting there doing that. We can't hear it. So let's do a couple of basic things here. Vary the B plus up and down a little bit. It's on the 150 volt scale now, reading 45.
Your next favorite podcast could be waiting for you right now on the Curious Cast podcast. Like it's nighttime. Join host Jordan Bonaparte for true crime, mysteries, the paranormal, and the weird from all across Canada. From music to history to true crime and more. It's all waiting for you now for free at Curious Cast.
It's 55 volts. On here it says 45. output tube takes more voltage, but we're not really driving an output tube here. So just seemed to me to get louder and nothing more than putting more and more volts on it. Next thing we could fiddle with. Not a lot. There's not a lot here. The volume control. And it just goes wild. Look at this. Don't hear anything. That meter's seeing something. That's pretty good. Seems to track with the volume. Oh, well, it shouldn't. It should be jumping with the voice. So whatever I'm doing is changing that thing that's driving this meter. I think it's a DC voltage. I've got a capacitor in there. How can that be? Strange, eh? Because I examined this control and it didn't seem to really be a spot. There sure does seem to be a spot when you operate it. .640. There we are. We finally heard what we're tuned to. Some fault in the capacitor right at this frequency.
The COVID-19 pandemic will cause an abnormal increase in Canada Pension Plan premiums starting today as a result of more lower-income workers losing their jobs. Dan Kelly, president of the Canadian Federation of Independent Business, estimates that anyone around the maximum CPP earnings limit will effectively see a 9.3% increase in premiums in 2021, beyond the just over 5% bump that was baked into law.
And that's going to be hundreds of dollars of new CPP premiums out of paychecks of middle-income Canadians. Now, because they're going to raise, but because the formula has not been adjusted, has not had a COVID adjustment.
CPP premiums were already set to increase as part of a multi-year plan approved by provinces and the federal government 4 years ago. The aim of the increase is to boost retirement benefits through the public plan by increasing contributions over time. Alberta's opposition NDP says Municipal Affairs Minister Tracy Allard made an unforgivable error by traveling to Hawaii for a holiday during the COVID-19 pandemic. CBC News reports that Allard returned to Canada on Wednesday. Premier Jason Kenney is expected to address the calls for Allard's resignation later today. A Wisconsin pharmacist suspected of ruining hundreds of doses of COVID-19 vaccine has been arrested. The Milwaukee area hospital says the health worker deliberately removed 57 vials of Moderna's vaccine from a pharmacy refrigerator Christmas Eve and again on Christmas Day. ABC News medical contributor Dr. Alex Patel says...
So just rotating that coil, I think it's just changing the coupling and the strength of the local oscillator being presented up here. It's also causing the oscillator to drift a little wee bit as I adjust it. But it's fine where it is.
Police say the pharmacist was arrested on suspicion of reckless endangerment, adulterating a prescription drug.
In case you're wondering what I'm doing, I'm listening to the news.
Poorer countries will soon get access to a COVID-19 vaccine that is already available in Europe and North America.
Oh.
Reporter Claire Bauer says emergency use authorization has been granted by the Public Health
That changed things, didn't it?
United Nations.
The World Health Organization has given the green light to the Pfizer-BioNTech vaccine, opening the door for UNICEF and the Pan American Health Organization to begin procuring vaccine doses for distribution.
Every nation that has its own regulatory agency will have to issue its own approval for the vaccine. The poorer countries with weak regulatory systems usually rely on the WHO to vet the shots. And musical duo 21 Pilots already have multiple gold and platinum records, and now they have duo. Guinness World Records certified the video for Level of Concern as the longest music video. The video ran for 177 days.
No, hey, come on. No, give me a copyright hit by doing that.
25 seconds.
No music, please.
Coming to an end on December 16th, when the band tweeted that
Well, we know it's 6:40. So we should be able to figure something out from there. We know it's 640. We know what the local oscillator is. We must know what the IF is. We must. Let's just verify all that.
Sports, the NBA is ringing in the new year with a full slate of games. There are 10 matchups on the skid today, starting with a tilt between the Memphis Grizzlies and Charlotte Hornets. And the Lakers taking on DeMar DeRozan and the Spurs.
Okay, local oscillator is, just one
2020
second.
on a winning note, beating the Knicks 183 last night. Fred VanVleet and Kyle Lowry combined for 45 points in the victory. The matchups have been set for the quarterfinal round of the World Junior Hockey Championship in Edmonton. Canada will face the Czech Republic, the U.S. will meet Slovakia, Sweden will play Finland, and Russia will battle Germany. The quarterfinals take place tomorrow, followed by the semifinals on Monday, and the medal round on Tuesday. Team Canada...
Turn this down. I think we're going to whip Finland's rear end in hockey today. If you like hockey, watch the juniors. Wow. So if the local oscillator is at 566 and we're listening to 640, this just doesn't make sense. What is happening here? So 566. We're listening to 640. That's 80. It's 80 above. The local oscillator is 80 below this signal and we're listening to it. We should move the local oscillator to 80 above. So 640 plus 80 is 720. How many times have I done that calculation now? Okay, so we want to move the local oscillator to here and we should hear 640 again. What are they talking about? Here we go. Okay, so now we're not quite 7. Where are we here? We're at 714, and we're picking up 640. I'm going to try to calculate that in my head. Where am I? Can't find my calculator here. Okay, so 640, if this were 710, it would be 70. 75. 75 is the IF frequency. That would mean, right now, if there were a signal 75 kilohertz on either side of this, like one here and one here, we'd be hearing it. Except it'd be suppressed by the front end tuning, which is aimed here right now. So it would suppress these signals. Now, as for the image occurring here, because you can go 75 above or 75 below. 75 below, you find 640. 75 above, the sharpness of the tuning of this radio is not very good. So if there were a signal up here, we would hear up at 75 plus 790. There's no signal at 740. I can make a 790. I don't think I need to. I think it's absolutely true what I'm saying. This radio suffers horribly from image rejection problems. But if the name of the game is to turn the dial and get something on the speaker, and the dials don't even have calibrated numbers on them, then you wouldn't be necessarily aware at all what's going on with these local oscillators. You might not even know where the signal may appear in a couple of places. It may appear in the wrong end of the dial. All these things could happen. But as long as Dad's happy that you managed to tune in the radio for the family, you're going to get your cookies at bedtime. The other thing I think that would be really apparent is the local oscillator screaming out of my antenna here in my house right now. And this should be easily picked up by other radios. We should give that a try. I have another radio here, but it's a tricky one. Let me go get a little portable radio. We'll find out if this local oscillator signal is... Well, actually, you know what? I'll take that back. It's not cast out my outdoor antenna. I'm on the loop antenna here. So... it could easily be on that loop antenna. I can still check for that. Let me get another radio. What I think used to happen, what I think used to happen is people would be hearing other people's local oscillators coming in on their radio. So you'd be listening to the radio, and all of a sudden that'd be somebody tuning past. So just have a portable radio here.
I feel like it's more than just about dancing. What are you hoping to get people to get?
AM. And the local oscillator is at just 720. Oh, dial in 720. Oh, this radio's crummy for tuning. It's just, yeah, crummy radio. Let's tune this guy. I think you'll hear this tone come and go. Yeah. Now, how far away can I hear this? A funny sound to it. Seem to be particularly broadcast from the antenna. Oh, son of a gun! Hold the fort! Nothing like throwing a wild clip lead into a radio like that. Yeah, I don't know. Well, it's there. I mean, no surprise, right? Surprising it's not coming off the antenna as much as it. And that was kind of a lousy test. Well,
Now, but in hindsight, we would never do such a thing.
what more could I do to this radio? Do another IF alignment deal on it. We'll try that one last time.
So much more, and it's given us a lot of perspective. Let's go around quickly and maybe 30 seconds each. Did sports handle it quickly enough? Would they have been more proactive before March 11th? So start with you on that. Was there more to be done? Did it look like they were very much late arriving to the party in a lot of the major sports?
To be honest, I don't think that they knew too much about the virus, and that was the key right there. They didn't know anything about the virus. They were paying attention to things happening abroad and seeing what other leagues were doing, but they didn't know enough. But the way they handled it after, I have to say, the NBA and the NHL, they did a good
See her
job.
voice bouncing on the meter here.
The other leagues, not so much.
And Mike, there was already starting to be games in Europe, Serie A in Italy and the English Premier League, where they were playing behind closed doors. And we thought, what a strange thing. That doesn't happen in North America. It made every sporting venue in Europe look like a Tampa Bay Rays or Florida Marlins home game in May or June. It was a strange sight to behold, but we never got there. We were full stadiums and then boom, shut down.
Yeah, and I think that you have to look at the way that any larger organization, be it government, be it sports league, the way that they have to handle this is a lot like parenting. Look at how you have to parent. Each and every day you're faced with some kind of question, some kind of challenge. You kind of make up the answer. You don't know whether it's right, but you try and give the most credible answer that you can, and then we throw a whole lot of hope into it. And I think that's
Minimal effect from this one,
organizations and
but it's
governments
there.
handle this from the beginning. So when we look back, hindsight, could things have been different? Could things have been done more efficiently? Perhaps. But
There we go.
again, you were dealing with so many moving parts. The idea to just shut things down was probably the safest thing to do. And now we're months after it, and the question is suddenly turning to...
This last one was really sensitive, if I remember right.
Again, and you'll wonder if that's the right thing to be doing or thinking at all.
John, we'll get there, certainly, but you remember out there covering the Canucks in Vancouver, the NHL, people were waiting. The NBA had already suspended their season and felt like we waited an interminable period of time. It was only a day.
Sounds pretty good to me.
For the NHL to say, no, we're following suit and we're shutting down our league also. But people weren't sure at the time whether Gary Bettman was doing it or not. Yeah, absolutely, because the NHL, Gary Bettman...
Well, I think that's it for today. I'm not finding anything that I can do something more about to make this thing work better, and it's working really quite well. I'm stunned. There's a couple things I can do: clean it up, make it look better, and there was something else that came to mind. I've just forgotten now, but that's okay. So I think we're in the last stages here of this radio. Unbelievable. Great. Okay. Well, thanks for watching. I'm not sure if I'm going to show this radio again. Maybe I will. Maybe I'll clean it up and show it one more time, or this is the end of the road, and I'm back to one of two other radios after this. I think this is it. Hey, thanks a lot for watching the series, and I got a lot out of this. May not look that way, but I got a lot. Okay. I hope you did too. Thanks again for watching.